All righty.
Excellent. Let's get started. So first of all, Amos, thank you for being our guest speaker for today. This is a fortnightly series that we are starting for skill development globally, but primarily focusing in India with our efforts to not only focus on skill development, but beyond that, how we can develop an ecosystem of semiconductor in India. So in this series, we have been getting different speakers, primarily from high-tech area. Last 2 weeks back, we had Thrive DX, an Israeli company, speakers from Thrive DX talk about cybersecurity. Today, we're going to talk about semiconductor. But before we dive into the topic, I want to kind of give a brief background of our keynote speaker today. Amos Dor, who serves as the head of Pharma vertical and is the CTO at Applied Materials AGS Automation Product Group. I can proudly say that I have known Amos back since 96, 97. When he was the business unit manager managing the yield management solutions department. We had products in fuzzy logic based signature analysis. That's where I first started interacting with Amos. I've seen him kind of be innovative in many fronts, not only with new products and companies, but also driving innovation with large organizations like Applied Materials. He started his own company also, which was Wafer Yield. Later on, got acquired by PDF Solutions in 2003. He was also with MKS Instruments, but now he's with Applied Materials. Without taking much time, I'm going to give the floor to Amos because everybody here is looking to hear from you, Amos. Let's kind of hear from Amos on unlocking the potential of semiconductor technology, insights, automation, and job opportunities. Amos, floor is all yours.
Gee, you make me feel so old now. We know each other 25 years or more. Wow, it's crazy. Okay, let's move to the presentation and let me make sure you see the presentation.
Yeah, we can see it.
All righty. So thanks again, Baljeet. I'm going to talk around 30, 40 minutes about semiconductor. I will give you highlights about the semiconductor, then going into the smart factory scene, which is computer integrated manufacturing. It's a combination of around 20 different products that we are offering to the semiconductor, and not just offering, we have around 95% penetration to the semiconductor market, and we are in other markets as well. So I'm going to talk about this, a little bit customer story and summary of everything, and then there will be questions that you can ask. So let's start with the introduction of what is Applied Material. So Applied Material, I'm even older than Applied Material, but Applied Material are pretty old. We celebrate 50 years 5-6 years ago. So this is where Applied started. It's very common to show off your garage when you start the company. So this is the Applied Material garage in Mountain View, not far away from Google headquarters. So this is where we started. Today, Applied is the number one company that supplied the equipment for Intel and Samsung and Toshiba, and I mean the list is very long. It's all the semiconductor and display, so everything that you see around you, like the monitor that you're watching this presentation, or your iPhone, or anything that got chip or display. At least 1/3 of the equipment in those plants are manufactured by Applied Materials. It's around $23 billion revenue a year. 2.5 billion go to R&D, what we just mentioned, CT organization or the R&D organization inside the business units. Lots of patents. The stock is doing pretty good. Not as NVIDIA, but pretty good. Headquarter in Silicon Valley in Santa Clara, and around 27,000 employees in 17 countries. We have our group for sure, and Applied in general, got big offices in India, Singapore, Israel, lots of places in Europe, lots of other places in Asia. So we'll show you later the map of the main location. Just talking a little bit about Moore's law, talking about every 18 months, the technology is shrinking by 2, become more sophisticated by 2x. Today we are getting close to 2 nano, the size of the technology, which is, it's a magic. It's unbelievable that we can go to those kinds of sizes. If you try to understand what's 2 nano, DNA is around 1 nano. If you put 6 atoms of gold, it will be 1 nano. So we are getting to those levels. Your fingernail growing is every second 1 nano. So this is kind of amazing capability that semiconductor is doing. And I think Bill Gates was saying at some point that the best thing that we got from the Russian is a Sputnik, because we lost who's landing first on the moon, but then we start the semiconductor. So if you look at the start of this graph is around 1970, and we had a big push to create those semiconductor. And as you know, today there is the CHIP Act in the US and in Europe as well, when there is again lots of investment into the semiconductor. So this is super important to see the amazing growth and the capability of the semiconductor industry. What is in very high level, what is the semiconductor doing? There is 2-3 things that are in very high level. One is adding material or creating. So this is creating the nano scale. In this case, it's copper on those chips. And if you try to understand how much, what's the size of it, or if you look on a half an inch of square inch of a chip, it's around 20 miles of copper wiring. If you look on the second thing that we are doing, the other equipment is more on etching or removing material and drilling holes and connecting the structure of the transistor. So this is another area that we are creating all kinds of chambers to do this. So by creating and removing, you have around 1,000 steps when you create a chip. You can create a transistor, so you can create the different memory, etc. And then once you do it, you want the yield to be very high. And in semiconductor, the yield is getting very close to the 98% plus minus. And to do this, you use all kinds of analysis, all kinds of optical microscope in the beginning and electrical microscope if you really want to go into the 10 nano and below levels of finding defects on the wafer. And this is, by the way, when Baljit and myself start working together in the 96, 97 on those areas of analysis of those chips on those wafers. Now, when you try to do those imaging just to get the concept of try to find those defects on the wafer, it's like you fly 5,000 feet pretty fast, and then you try to find a dime in Manhattan. This is kind of the level of technology that we are supplying our customer and help them find those defects, and not just finding those defects, also find the ways of the procedures to not to have those problems again. In some cases, even to fix it. but not to have those problems again, and to minimize the defects that they have on the chips, that they can put it inside the devices and the devices will work. If you look on iPhone and you use the technology of the 80s to create this iPhone, it will cost you 110 million. Then it will be like 14-meter high. So back to the every 18 months, the technology shrink by half. This would bring us into the capability of creating the technology in the automotive, the technology in the communication, like the iPhone or the smart watches and all those things. So those kinds of capability, again, it's amazing to see the improvement in the technology, where we are going. And you think that you're going to hit a wall, and then you continue and continue, and we'll see where we can get. So that's amazing. From the periodic table, if you guys remember, last time I was playing with this was in high school, so this is long time ago. But if we look on the different material and say, okay, what material we use in the 90s, you talk about only 5 type of material, mainly, I mean, silicon, of course, and aluminum. This is what we use in the 90s, going into before 90s. If you go to the 90s, we had copper and other material. And if you talk about after 2006 or today, it's basically lots of material. So talking about building chambers to build those chips, our customer use all those materials that are in black, orange, or green. So lots of capability from what material to use and how to build the chip that they can do what the customer need them to do. What is the factory, or what we call a fab, semiconductor fab? So a typical fab today is it's around $15 billion. There is a small mistake here. The 2x, the cost of the fab, is every 4 years, not every year. So every 4 years, I mean, 4 years from now, building a fab will cost $30 billion. So if let's say India want to build a fab in India, the investment today is $15 billion, which is huge. So governments and companies need to build those plants, to invest lots of money, to get the right technical capabilities. So it's not an easy, and then you see that you cannot find fabs of semiconductor in every country. You need a big investment, and not every country is willing to put this investment. The advanced fabs are doing around 120 wafers, 300 millimeter wafers every month. There is 1,500 equipment, usually 1/3 of them are from Applied Materials. They need 1,000 employees to run this fab. And when you build a product inside those fab, let's say it's a chip for a car, for example, for Tesla, let's say, it will take you around 90 days from the starting of building the chip till the chip is after test and ready to use. And then, since it's so expensive, the customers, together with us, are trying to make as close to 100% success or yield for the chip that they are developing in those facilities. So 5 to 6 sigma, this is where they're trying to, not trying only, they really succeed to run it in those kinds of process capability and productivity. We in the automation groups, we're also selling to pharmaceutical and and battery and other markets. We'll talk about it later. But if you look on the equipment productivity or the uptime of those equipments, in the semi, it's close to 90%. You do maintenance, you do cleaning, you do all those things. In pharmaceutical, it's around 50 to 60%. So the semi is all about OEE, all about getting the fab running all the time with maximum yield and maximum speed. And when you get all those things, you can cover the investment of the $15 billion per plant. Applied long time ago, when Applied started in '67, it was building the unit process on the left side. It's kind of one unit that do a specific thing. And then Applied came with innovation of integrating the platform. So you have in the center the mainframe, everything is in vacuum, and then you have the different chamber that are doing the process to build the chip. They're all connected together, and then you can do it much faster, much cleaner. Then adding capability, there was acquisition, I want to say 2005, no, before, it's 90 something. There was the acquisition of the inspection for Applied, and then integration of the inspection together with the process tools and selling those solutions together with the software that I'm going to talk about soon. All those capability and integration are what make those fabs working together, and the ability to create those high yield and high efficiency. So what's the opportunity beyond semiconductor that we are looking at, or including semiconductor? So in life science, AI, which is, as you know, become bigger and bigger, and you need more and more servers, more and more advanced chips, very strong energy storage, getting into 3D printing, getting into coating. In this case, the picture is engines, so coating engine blades, or coating even when we go to pharmaceutical, coating pills in pharmaceutical, optics. There's so many things that either the applied material capability on building or the technology that we're doing, and the software that we're using in the semi, we're using it in those areas as well. So lots of potential, lots of opportunities for the future. Let's talk a little bit about the Applied Global Services and the group that I'm part of inside Applied Global Services. So when we sell those tools to the Intel and Samsung, etc., TSMC, etc., we're selling the tools. 1/3 of them is applied material, so 5 billion plus minus of the fab is applied material equipment. We need to service. We need to install the software around it to run it and to monitor it and to predict when it's going to fail, so we can fix it before it's failed, etc., etc. So the Applied Global Services, it's around 1/4 of the applied business, and we are part of it. So this one is giving the support to the customer to run the equipment. This one is giving advanced tool to do analytics, advanced tool to monitor what's going on. And this is what our group, the Applied Automation Product Group, is doing, those software solutions. So we can predict, we can solve all kinds of problem, we can optimize the current way that fab is working. And we have lots of people that are doing consulting to help. So let's say a new country decide to get into semiconductor, we have lots of people with tons of experience that can deploy together with the system, and then we can. Baljit, I need to answer this poll right now.
Not for you, Amos. Let the others do it.
I can't speak and put those things together. So we offer automation solutions. We offer the consulting, and we look not just on the fab level, but also on the supply chain level. And it's all about performance, yield, and increasing the output, or the OE, as we like to call it. So the automation group is around, I think we are very close to 1,000 people right now. It's based on a couple acquisitions from 40 years ago. And we are in the semiconductor mainly, but also in solar, in display, in pharmaceutical, and getting into battery, chemical. We got probably around 10 different verticals that we are going after. But again, the main thing is semiconductor, of course. This is what Applied is starting from, and the biggest business coming from. And we deliver those software and consulting solution for this market. Location-wise, so the headquarters in Santa Clara. This is location for the automation product group, not for Applied in general. So we have Phoenix, Salt Lake. We acquired a company in Manchester a couple of years ago, Boston, in China, Chennai and Bangalore. We have the two big offices of Applied, and more specific for the automation product group. Singapore, I just came from there a week ago, Taiwan, Japan, Korea, and other places that are not here, like Israel and a couple other places. So around 19 countries that we have people, and talking about opportunities, those are places that we are also looking for engineers, and there is opportunity in those areas. Let's talk about the Smart Factory, the Applied Smart Factory SIM solution, which is the integration of all those 20 plus different software products that we have. So when you start a process, let's say you have a new technology that you want to deploy in a fab in Taiwan, for example. So you start with ramping, and then you get into a point that you know how to run the process, and you try to keep it as closer to the 100% yield, or a combination of the yield, output, and the productivity. Our software are trying to push to the S-curve that is the best, faster yield, faster ramp, and higher yield, and those kinds of capabilities. So we have four main product or family of products. One is focused on the process quality, so improving the yield, for example. The other one is in factory productivity, how to move the wafers or the cassette of the wafers to the right place in the right time, and how to optimize the scheduling or the dispatching in those facilities, the manufacturing execution system, which is tracking what's going on, and the supply chain, so it's even beyond the fab, the factory itself. So those are the four main family of products. If we get a little bit deeper into what we are doing, so in the factory productivity, the main thing is understand what need to be done and optimize. So understanding the workflow, scheduling it, planning it in advance, planning it even before you build the facility. You can understand what equipment you want to have to maximize the throughput. We do prediction when we think this wafer is going to be ready, or a batch a lot of wafers. Is it going to be ready in July 18 or is it going to be ready in July 15? The reporting of all those things. This is the factory productivity. Going into manufacturing, so the manufacturing execution system, this is looking in the work in progress, understanding the workflow, and making sure that we are managing the material, managing the cassettes, the wafer cassettes, and run it. In those fabs, we didn't talk about it, but in those fabs, the 300 millimeter and all the new one, everything is automated. So you have full automation, and you want to make sure that you give the instruction to the equipment how to the fab, to the full fab, how to operate and maximizing the efficiency. So this is part of the MES system. And then when we look into the process quality, this is in the area of collecting the data. The data can be process data, can be imaging or classification of defects, and understanding all those things to control, predict, finding the fault, and more than this, also telling the operators how to fix, how to make sure it's not happen, all those capabilities. And this is where when we can see more and more AI getting into the systems on ability to predict and the ability to give instructions to the operators how to operate, how to fix things. And the last thing is the supply chain, and this is become very important when you start looking on multi-sites and where the raw material coming from and what's the priority of each product. So you can organize all those things and go into from high level into the fab level. So those are the 4 families of products that are part of the SIM solution, the integrated solution. It's combined of around 20 different software solutions that in some cases the customer will buy only subset of those 20. In some cases, they're buying the whole set of the SIM solution of Applied Materials. Looking on those 20 plus software, so I'm not going to get to each one of them, but if we look on the green one, this is more focused on the manufacturing execution system. So looking on the cassettes of the wafers where they are and make sure the maintenance is done in the right time and all those things. The blue one is more on scheduling, dispatching, prediction of cycle time, those kinds of capability. Everything is connected through a message bus. Those kind of things are right now we are can run them on the cloud as containerized. Some of them are containerized already, some of them is still working. So this is one of the things that we are moving to ability to deploy on the cloud. The red one is more on the quality or the quality and control. So SPC, fault detection, those kinds of capabilities, yield management, defect management, knowledge advisor, which is taking all those faults and advise on how to fix it. And all those things, all those software things in the colors are on top of the gray one on the bottom, which is the process equipment or the metrology or advanced sensor that are coming from partners of Applied in most of the cases. And AMHS, which is how to move the cassettes between the different tools. All those hardware we are connecting, integrating to those hardware, to those equipment, and run the software components. If we look on the evolution of manufacturing and semiconductor is on the right side, but other, I put an example of pharma here, but pharma, battery, automotive, every vertical is in a different phase, but the phase is in the beginning, there is basic, no automation. If it's a very simple chemical plant that just mix the material, in some cases they don't have any sensors, any automation, they just do it. So this is kind of level 0. You move to level 1, which you got operator, there is some data collection, you try to understand what's going on. In level 2, you start moving to automation, robotics, and things like this, that you control the process better. And then you move into an area that you collect lots of data, you do prediction. This is what we call the conditional automation. You start doing a digital twin, you do some machine learning, and then you move into high automation. You add some decision-making capability that coming from the AI and the system. And then eventually, if you go to full automation, which we have customer with full automation, so it's not a dream, it's reality. It's lights out, the plant is operating, everything is automated, and you need operators only if something is broken and you need to replace some part. So from no automation at all to full automation, different verticals, we have customer in all those areas. So this is my presentation, high level. I think now we have some questions, Baljeet?
Yeah, Amos, I have a small part to cover and then we'll come to Q&A.
Okay.
So first of all, I really want to thank you. It was quite detailed and gave us a good overview about how technology is moving in automation space in semiconductor. So just to kind of bring everybody to speed, what Ajuba is trying to do in this space, what we believe is skilling India is important. So we have taken up 2 major areas right now, semiconductor and cybersecurity. And I'm going to talk about both of these, what we are trying to achieve. So let's kind of look at the potential of semiconductor market. You know, there has been a lot of studies done. In 2021, this is the data from that, there has been almost 1.14 trillion chips that were sold worldwide, which equates to close to 140 chips for every person on the planet. So semiconductor is coming to India in a big way. There is already 7 large partnerships being announced for manufacturing fabs that are coming to India. Applied Materials and other equipment manufacturers are already present. And I believe this thrust that the government of India is making is going to make it happen. And so there is going to be a lot of jobs that are going to be coming up in this area. These are typical jobs that are out there in semiconductor. You can become a semiconductor engineer, equipment engineer, process engineer, field application engineer, customer service engineer. So there is a lot of opportunities since this is a new manufacturing market in India. And I'm going to switch from semiconductor to cybersecurity for a second. Cybersecurity is an important area also. Just to kind of give you numbers, last year, 14 lakhs, which equates to 1.4 million cyber attacks happened in India. The most recent one was the Suzuki motorcycle India, which they halted the production for a week, which resulted more than 20,000 units that were not shipped out. All major organizations, not only in India, but globally, I would say cybercrime is at high rise. Every challenge brings opportunity. So just to kind of give you some numbers, by 2023, cybercrime itself is going to be about 8 trillion. That's going to be the damages that are happening. So if you look at the GDP numbers, that'll become a 3rd largest economy after US and China. Now, this challenge is also bringing an opportunity. Worldwide, there are 3.5 million jobs that are unfilled. 3.5 million is about 35 lakhs, which is equivalent to 3x population of a Chandigarh, which is a city in India. So there is a lot of opportunities in cyber security also. So what are we trying to achieve here? So what we are trying to offer this year, we will grow with our offering, is first is we just launched an online program for cybersecurity. It's an introduction to cybersecurity that we have teamed up with Thrive DX. It's an Israeli company with their content and labs for introduction program. It's a 10-week online program. We are also offering postgraduate diploma. The postgraduate diploma is both in cybersecurity as well as semiconductor. It's a 1-year program with a 6 months paid internship after that. So we'll come into, so for both these programs, any engineering, be it you have a 4-year engineering degree or a 3 years, you can be part of this postgraduate diploma. So an engineering degree or a 3-year college degree is required for cybersecurity and semiconductor. Just to kind of give you what's the online introduction program, it's a 10-week program starting on July 1st. It'll be every Saturday from 7 p.m. to 9 p.m. India time. So that's going to be online instructor-led, and then 1-hour lab that an individual could do it. And it is 15,000 Indian rupees. It includes all your platform, online platform, all the exercises that will be done in this. Now let's talk about the postgraduate 1-year diploma. So what we are offering is a 1-year postgraduate diploma. This is in partnership with Rahat Pahara University up in Punjab. So student will have options to take both cybersecurity or semiconductor programs. The program is such that student will spend 9 months in India, and then they have, for the advanced learning, they have 3 different options. You can be in India and do advanced learning over there, but that's going to be more towards only design part of, for example, semiconductor. Or you can come to US. We have partnered with Rochester Institute of Technology for a 3-month advanced learning program, both for semiconductor as well as cybersecurity. Or you can go to Israel also. So, and then is your, now those 9 months, if you look at it, what we are trying to do is, we will not only impart technical knowledge, but also soft skills. We believe soft skills are very important in the learning journey of a participant or a student. Now, the internship that is going to be there, it's going to be for 6 months, and it's going to be with paid internship. And it is globally. It could be anywhere in the world, and we are doing tie-ups with various large organizations to make this offer to the students that be part of it. Now, just to give you a little bit options, because everything comes with cost, and there is a value attached to it. So what is it is going to cost for a postgraduate diploma for 1 year? The 9-month part is same. So this fee structure is both for semiconductor as well as for the cybersecurity. For the 9 months that you are spending in India, you will have a fee course of 2 lakhs. And then there is an overseas coordination and management fee of 1.5 lakhs. On the other side, if you opt, so you have 3 options: USA, Israel, or India itself. So if you opt for USA, it is 15 lakhs for the advanced training. The housing based upon twin sharing, it is 2.21 lakhs. And the travel and visa fee, it is 3.5 lakhs. So this is if you pick USA with RIT as an option for advanced learning. If you pick Israel, advanced, the fee for 9 months remains the same. The advanced learning is 9.5, 10 weeks housing is 1.23, and travel and visa remains the same. If you opt for India, so in India, it'll be only design, it won't be hands-on clean room manufacturing experience. It'll be more towards an advanced learning and design environment. The fee for 9 months is only 2 lakhs, and the advanced learning training part will be 1.5 lakhs, and then we will have a 1-week trip to a company in Bangalore. So that's about 50,000 rupees. So this kind of gives you all the different models that we are offering to students. Just to give you some numbers on 6-month internship. So like I showed you early on, an average engineer earns about 97,000 per year, which equates to about 6.66 lakhs per month. Average internship that starts is about 3,500 US dollars per month, which is about 2.87 lakhs. So in 6 months, it's about 17 lakhs a student will earn. So if you look at it as whatever you spend in US, you're able to make that in 6 months. So it's a great benefit. We are giving all the options to students here. I'm going to pause here for our Q&A session, and then we'll talk about our next webinar. So Amos, first of all, thanks again. During the registration, we had several questions that came up. So I'm going to ask a few of those to you. So number one, how are semiconductors transforming industries apart from telecommunication?
Yes, so I mentioned a little bit of it already. There is impact of semiconductor in areas we see a lot in battery, solar. We talk about display. We talk about pharmaceutical. Those kinds of markets are becoming more advanced. Some of them, it's because it's very close to. If you look on solar compared to chip building or manufacturing, it's simpler, but it's the same idea. A battery, it's very close. But even if you look on pharmaceutical, life science in general, medical device, those kind of things, we see the impact of what we are doing in the semi in those areas. So it's lots of different new markets.
Excellent. Thank you, Amos. Next question, Amos, is why is, I believe you touched on it, but specific question, why is automation important in semiconductor manufacturing?
So when the process become more and more sophisticated and you need to take a decision very quickly, I mean, if you look on a fab in TSMC, for example, they're doing around 700 different products every month. And there is 1,000 different steps in those 3 months that the product is being built. All those things, if you want the efficiency to be high because it's so expensive to build those fabs, you must move to full automation. You must move to a place that you can do everything very, very quick. And this is very automation. Even if you go to pharmaceutical and you talk about cell gene therapy that you need to do for every different patient, a different batch, it's become so complicated. You cannot do it manually. You must move to automation.
Thanks. Next question, Amos, is what advanced technologies are used in automation in semiconductor manufacturing?
Lots of them, just a couple example, prediction. So ability to predict when you need to do maintenance or prediction if the wafer will be high yield or low yield. Machine learning that use historical data to predict how to run the current batch. Those kinds of AI prediction, automation, all those are very advanced technology.
Next one, how does the integration of MES, manufacturing execution system, with other manufacturing systems impact overall efficiency?
So as you see, when I was talking about the SIM, the computer integrated manufacturing, it is a combination.
I'm not sure.
Sorry about my Siri. So you connect all those things together. And for example, if you use the scheduling and you predict that the batch will end in 3 days and not in 4 days, you can plan how to use your tools, your equipment much more efficient. So connecting everything together create another level of efficiency. So very important to integrate and to use data from different system in the other systems.
Mm-hmm. Great. Next, I'm going to ask two questions together because this is interlinked. What are some of the career opportunities, in fact, within your division, Amos? And also, somebody just kind of asked right now, what skills and qualifications are in high demand?
I think, as you mentioned before, Baljit, we see more and more investment in India from the government, from applied side. We have offices in Chennai and Bangalore, and we are looking for people in those offices and beyond all the time. When we look on software, this will be kind of software engineers. It will be people that are specialized in image analysis, those kinds of capability. But if we look into the global applied, it's process engineers to work on the equipment. It's customer engineers to give services. This is the main thing. I think Applied is looking in the next 3-4 years for another 10,000 employees. So there is huge opportunities in Applied.
Excellent. The next one, Amos, is how can semiconductor technology enhance the capabilities of 6G in defense applications?
16 different applications.
6G, the telecom.
The 6G. Each time you move to a more advanced technology, like from 5G to 6G, you need a more, we talk about the technology, you go down from 10 nano to 4 nano to 2 nano. So this is definitely area that Applied is the biggest player on building those equipment to do it. But beyond the capability to manufacture it, it will give you faster communication. It will give you ability to run more sophisticated algorithms. All those things together are, we see the engine for Applied to grow, and also the engine to be deployed more sophisticated analytics, more sophisticated technology in network and AI, etc.
Excellent. Next one, Amos, is in previous years, even now, there has been great supply issues in semiconductor manufacturing, availability of the chips. But if we come more specific to an equipment manufacturers, how do you see the demand with all the manufacturing fabs coming up in India and globally?
So this is a little bit outside my expertise, but let me still try to give you some idea. So yeah, there was a big supply chain issue, still is a little bit during the last 3 years. And Applied invest a lot on how to find different way for supply chain, more vendors to work with, all those capabilities, and also our software. If you look on the supply chain capability that was part of the software I present, it's looking on how to help our customers to optimize the supply chain issue. You need to, I mean, this is part of if India is moving into this area, you need to make sure that you have not just the fabs, but all the second tier and third tier supply chain, making sure you have all those capability to supply the material and to ship the chip to the right places. It's a very big effort to make it available, but very important.
Thanks. The next question I'll take up is for me. Somebody just asked, what will be the timing of the offline course at Rahat Bahara University? So there are two types of courses that we are offering. First one is the online 10-week program for cybersecurity. It's an intro to cybersecurity. It's an online program, but it is instructor-led. So every Saturday, starting from July 2nd, every Saturday from 7 p.m. to 9 p.m., 2 hours will be instructor-led online. The other two programs that I've talked about, the postgraduate diploma for cybersecurity and semiconductor, these are one-year programs, and it has 9 months at Rahat Bahara. So it's not an offline program, it's on-site. 9 months at Rahat Bahara University and 3 months advanced learning. In advanced learning, you have 3 different options. Either you can take that advanced learning in India, US in Rochester, New York, or Israel, because the cost structure is different for each of those advanced learnings. Excellent. One final question, Amos, is in yield management, the stringent requirements because of the technology move has been happening from year on year. How do you focus your innovation drive in software development in building and yield management software, for example?
So it's take us back to the question of why MES is integrating to different system. I think it's not just why MES it's integrated, it's how we create an environment that all the systems are integrating and talking to each other and help the other system to be more efficient. So same thing when you talk about yield management, connecting the ability of yield management into the process control and take those data to build a more sophisticated deep learning capability on AI that will go into the overall control, monitor of the systems in the fab or in the pharmaceutical plant or in all those different areas that we deploy those combination of system. This is where we are going. We are going not to sell a yield management system here or a control system there. Is selling those SIM solution, the computer integrated manufacturing, together, that the yield management is part of it.
Great. Excellent. Let's go. I'm going to talk a little bit now on the upcoming program. As we started, it was a fortnightly. When we started it, we thought that let's do it on Sunday. Between last time when we did it and even today, everybody is coming up is let's do this fortnightly webinars on a weekday. So our next webinar is going to be on Thursday, which is June 15th, but at the same time, 8 p.m. India time. Our next keynote speaker is Dr. Nidhi Rastogi. She is an assistant professor at Rochester Institute of Technology, expert in cybersecurity and artificial intelligence. The topic for our next webinar is artificial intelligence and its role in cybersecurity. So I would request everybody to tell this. It's a free online webinar that you can join. We will start moving forward. It'll be every Thursday. So our next webinar is going to be June 15th at 8 p.m. on artificial intelligence and cybersecurity. So Amos, I really want to thank you for your time on Sunday. I know it's an off day. I really want to appreciate and thank you from all of us. It has been a tremendous learning for everybody. This session is recorded and we'll make it available on our website too.
My pleasure, Baljit. Thank you much for inviting me.
Thank you. Thank you, everybody who's online, and we look forward to continued learning. Thanks, everybody. Bye now. Thanks, Amos.
Thank you. Bye.